Hello. Hello. This is Eugene here again. And so this video is a continuation from our previous video on how to download R and use Markdown. And so we'll just continue to work on the same data set, which is the ds data-ec.csv. So we're gonna walk through how to import your data set, explore the data visually, because it is nice to have some visual as to what's going on with the raw data, analyze missing data patterns, and then handle missing data through multiple imputation. So first, let me show you how a quick and easy way, if you're one of my students, to integrate your assignment with Markdown. So if you were to click on the assignment that you can get from Moodle, this is how the assignment looks like. So there are the instructions at the very top over here. The link to download R, link to download R Studio. We talked about that already. And what I would recommend is doing this. Take this and copy this entire thing into your Markdown script. Okay. Once you do that, in here, this is just to make the headers. So this will ensure you will not forget to answer any particular questions. So let's just make them 8 and 9. All right. So first of all, we want to import the file into the global environment. Just like I mentioned before in the previous video, you want to make sure that your data set is in the same folder as your Markdown file. It's just one of the quirky things about Markdown compared to R. So let's do this. Let's insert a code, and let's call this the master dataset, and use the read.csv function to read from ds-data-ec.csv, and command enter. If you're using Windows, it's going to be control enter, I believe. All right, so you should see over here in the global environment that now you have a data set called master, which has 355 observations and 26 variables. And you can double check this in your Excel when you open up this data over here. It shouldn't be that much different. Okay, so next thing, use summary function to figure out how much missing data is in each variable. So that's pretty easy. Let's add another chunk here. Summary master. Okay, so we can see that the NAs are going to be missing variables, right? So for advising, we have 53 people with missing information in there. That's crazy, a whole lot. Just looking at the variables and number of missing, this is actually quite a terrible data set, which I guess is a good example to work from, given that most data sets that you would get in real life are going to be pretty messy, and this is a really messy data set. Okay, so we use the summary function to figure out how much missing data is in each variable. So a whole bunch of missing data that we need to handle over here. Next is use the view function to figure out to view the raw data. Sometimes I like to do this because it helps me to just visualize things. So again, let's go to init, and let's use the view function, and there you have it. So this should be exactly the same as this. If I were to pull this up in Excel, You have gender level, advising, Q1, Q2, and the roles are representative of each participant. And so this is just one really nice way to just kind of take a look at what's going on over here. So you can see participant number 4, it's a bunch of NAs. I have no idea why. This is actually not my data set. And so one of the reasons why you'd want to check for missing data, especially if this is a study that you conducted, and actually, even if it's not a study that you conducted, if you got this data from someone else, you should probably talk to that person and ask them, hey, like, what do you think happened? Because whoever it is that collected the data set probably would have more insight compared to you if they collected the data. So the purpose of checking for missing data patterns is to make sure that there isn't anything funky that's going on in your data set. Okay, so that's using the view function to view the raw data. Next is we want to use the names function to list variable names. And I'm just basically, the reason why I have you do this is so that you kind of know of some useful functions that you can have when you're messing around with your data, trying to get it prepped and ready for analysis. So names, these are basically going to be your variable names right here, which is pretty consistent with what we've seen so far. All right, and we're on to the next part. Examine missing data patterns. And so first thing that you want to do is you need to install a couple of packages in order to run Little's missing completely at random statistical test. So if you don't know what is Little's MCAR or MCAR test, it is basically a multivariate statistical test to help determine if data is missing completely at random, also known as MCAR, which basically means that the missing data, any missing data on a variable, is unrelated to other measured variables and is unrelated to the value of the variables itself. I would highly recommend that you read Missing Data Analysis by Anders. This is a 2010 book to get a more in-depth treatment of this topic, because you can pretty much have data that's missing completely at random, missing at random, and then missing not at random. Missing not at random is basically what you would want to avoid. Because that is when your missing data patterns are related to some unmeasured variable, and or that missing data pattern is related to the value of the variable itself. So that would be an issue right here. The disadvantage of using a multivariate statistical test such as MCAR or MCAR is that it can't really pinpoint specific variables that violate that could violate this assumption. So it's basically going to test the probability that data is missing completely at random on a multivariate level. So it does it on an omnibus or on a more global level. There's a paper that we wrote that basically we needed to demonstrate that, sometimes it's more useful to run a more nuanced univariate tests, or actually a series of univariate tests to see what variables may be related to missingness. Another limitation of Little's MCAR is that it assumes that missing data patterns share a common covariance matrix, and a lot of times it doesn't, again coming from real data sets from the messy world that we live in, and a lot of times there's also quite a bit of low power when there is when there's a small number of variables that violate MCAR. So it may actually be too it may give you a false sense of security, but anyways, it is a pretty easy way for you to do a broad multivariate test to see to check out the probability that this missing data pattern does indeed come from a missing completely at random distribution. So what do you need to do? is you need to download and install two packages, Baylor EdPsych and MVN MLE. I'm not even sure how to pronounce that, so I'm just gonna type this out. So again, let's put in some code over here. So first you're gonna install the Baylor EdPsych. Oops. Okay, you're gonna install that, and then you want to load the package once you install it. All right. Next, you want to install another package. Install packages, nvme, and we're gonna load it to. All right. So let's do that. Okay, it's going to. Let me install this first. There you go. Let's load that. And then let's load this. Let's see if we can put this up over here. Oops. Yeah. Let's install. I think it worked. Okay. Let's load it. Oh wait, it didn't work. It should work. Let's just go ahead with the rest of the analysis because I think it may actually work without that because I was going to run a particular function, but we may not need that anymore. But it does look like oh, that's the reason why. Sorry. Here we go again. So we did download it, and let's load it. Okay, I just misspelled it. My bad. All right. So next thing that we want to do is we want to run those tests and then interpret the results. So let's run virtual MCR on the master dataset. And it'll just take a couple of minutes to think and crunch some numbers. Typically it takes less than like a minute or two. So depending on the spectrum of the computer, it may take longer. Or shorter, hopefully shorter. Mine's not that a very fast computer anyway. Okay, let's go to the console. The results is that it is fairly significant. So that's just for the purposes of this. So that's pretty suspect, but let's just say it is not significant. It is p more than 0.05. So data should be missing completely at random. Okay, let's minimize that. So, oops. Sorry, I'm trying to, there we go. So to interpret the results, I want you to write something along the lines here of because P was more than 0.05, this test was not significant. Something along those lines. So, or you could say data appears to be missing. Missing data appears to be missing completely at random. Okay. So next, you want to make a custom function to calculate the percentage of missing data. I'm going to use this function to use later again across the rows and columns. So let's make this formula, this function right here. We're going to say percent missing equals to, and this is the function x. You want to take the sum of is.na, so missing values, divided by the length of x, and you want to multiply that by 100. So the length is basically going to be the length of the variable itself. So this will give you a percent of missing. Let's just run that. Oh, wait, I'm missing. I must have a typo somewhere. Got it. Double check. All right. That. Oh, sorry. There you go. Oops. So that should work. Spaces shouldn't make a difference. Oh, expected. Where is it? Expected close parentheses. This one. Okay, there you go. That worked. So now we just made a function. You can see over here that the function appears in the right-hand column over here. We can use this to calculate the percent missing according to rows and according to columns. So next thing that we want to do is we want to apply this to the rows. So let's calculate the percent of missing data according to rows across people. Okay, so go type apply, master, and this is going to be blank because we want to basically apply the formula to all of the people, and you want to minus or take away the columns 1, 2, and 3, because if you recall, is it over here? Columns 1, 2, and 3 are not going to be part of the survey or the questionnaire that we are interested in. So let's just remove that. It's what that formula is for. And 1 is basically row, we're applying this to the rows, and we're going to use the percent missing function. So this came from that, essentially. Okay, next thing is, let's minimize this. Okay. Create data set that selects rows and meet criteria. Okay. Let's make a table first before we go into that. So missing equals to apply. Space, applying to everyone, minus the categorical columns, 23, missing. So basically making a variable called missing that is going to be based on the percent of missing for each person, according to row, using this formula right there. And we're going to make a table. So this is the output over here, or this is the output over here. So we have 266 individuals who have 0 missing data, 6 individuals who have 4.34% missing data, 1% individual, sorry, 1 individual who has 13% missing data, and so on and so forth. And like I said, this is a really terrible data set because we have 70 people who have absolutely 0 data on this. What we're looking for is to only, because at some point here we are going to impute some data for people who have missing data. But we're not going to impute data for people who have too much missing data because we don't want to be making up too much data over here. And the general rule of thumb is if you have more than 5% of missing data, then we're just going to not impute data for you because we don't want to make up your data. And so what we want to do is we want to, first of all, so this is when we want to start partitioning out the data set over here. So first we want to create a data set that includes rows of participants that do meet the criteria for acceptable levels of missing data. So people who only have less than 5% missing data. So that should be 266 plus 6 over here. And how you can do that is, let's just call them replace people. You can call them whatever you want, replace rows, but whatever makes the most sense to you. So replace people from the master data set, missing that are equal or less or equal to 5. And let's keep all the columns. That's why you have this space over here. Okay. And then next, we want to create a data set that selects rows of participants that do not meet the criteria for acceptable levels of missing data. So let's just call them don't people master, and it's just going to be because more than 5. Oops, I have a typo somewhere. Oops, yeah, major typo. Okay, so now we have the don't people, and we have the replace people right here. If you add this, the number of observations, together with this number of observations, it should total up to 355 individuals right here. But you should still have the same number of variables. So we're going to take care of that right now. So next thing that we want to do is we want to create a data set that includes columns that meet the criteria for acceptable levels of missing data from the data set that was created in section B over here, because these are going to be the people that we do want to impute missing data for. Um, oops, sorry, this bug is still in this room. Okay, let's do this. Insert init. Let's call this replace column equals to replace people. Remember, because we're taking from this data set right here. Sorry, this is totally the wrong code. I'm way ahead of myself. I first need to apply that percent missing function to the replace people data set, so we can calculate the percentage of missing data according to columns. So apply replace people space, because we want all the participants, but we don't want those categorical columns 1, 2, and 3. And then so let's apply the percent missing function to the columns, which is designated by number 2 over here. Get that right? I think it looks right. Alright, there you go. Let's make a table for this. So to do that, let's make a temporary variable over here. Apply replace people, all the people minus the categorical column. Missing. You know what? I could have just copied and pasted that. But anyways, I did get that right. So, all right, let's look at the table. So it looks like these are the variables: question 1 to question 23. So question 1 has 0.36% missing. Question 3 is 0.7% missing. So 19 variables had 0 missing. 2 variables had 0.36% missing, and 2 variables had 0.74% missing. So it's still below the 5% cutoff. So that's good news, because we don't need to be excluding any columns as we partition the data set out further. But you can also see how that makes a big difference looking at the percentage of missing data across rows or people versus across columns. It kind of tells a really different story. So what we want to do next is we want to exclude the columns with too much missing data, which is pretty much non-existent over here. So let's do this. Let me show you. Okay, so the replace column data set is going to come from the replace people data set, which includes all of the participants minus the categorical columns. Right, and the reason why it's still pretty much the same as before is because there really aren't any columns that exceed the 5% thing. And the don't column is going to be replace people. The don't column is going to include all the rows, and that's also going to be categorical variables, just for the sake of completeness over here. So let's run this. One thing to notice is if you look at the global environment again, which is right here, you can see that the most recent data set that we created, the don't column, as well as the replace column, if you add up their variables, it's going to come up to 26 variables. So that's just one way for you to keep track of what you've been doing with your data set. We are systematically partitioning out the data set with our final data set containing rows to replace, which is replace people, as well as columns to replace, now named as replace column. Next thing that we want to do is we want to run mice. So install the mice library. That's going to be library mice. Alright. Next thing is we want to run mice to conduct the multiple imputations across multiple data sets. Again, if I haven't covered this already, multiple imputation is basically giving our best guess at the value of the missing data based on a regression model where missing data values are assumed to come from a normally distributed population distribution. It's called multiple because this is an iterative process done multiple times until estimated parameters achieve stable distributions before the data set is spit out, before it repeats the same process again. Through the mice package, R has a very simplified way, well simplified from our end at least, the user end, in terms of doing this. Downside is I still do not know how to use this to impute categorical data. So in general, if you're gonna use this method that I'm about to show you, you either leave out the categorical variables or just pairwise eliminate them. The book that I mentioned earlier, Missing Data Analysis by Enders, I think it was published in 2010. He actually outlines a more nuanced way of doing multiple imputation, which maybe hopefully in the future I'll be able to post a video about that. Because for that one I only know how to do it through M+, not so much through R yet. Okay, so run mice to conduct multiple imputations. So first, I'm going to create a temporary data set to run the mice function. Mice is going to figure out what type of data you have it and replace that with the kind of data that you have. It automates it really nicely, and we're asking mice to do it for the replace column data set because that's gonna be the data set that has the rows and the columns that we do want to replace, because those are the rows and the columns that are less than 5% in terms of their missing data. So let's run that. Alright. Just FYI, if you do run into an error saying there is no missing data, you could use the summary function to check if there is any missing data, because it might be possible that in the process of removing all the rows and columns that had more than 5% missing data, that you have virtually eliminated all of the missing data. So that's just something to keep in mind. At this point, we've only created some temporary data sets that are imputed, but your data set is still not filled in yet. You need to tell mice which data set you would want to be imputed into your data set of interest. So let's do this. Let's make a data set called miss, and it's going to be complete from one of those temporary no missing data sets. And this digit really can be any number between 1 and 5. It's just one of those data sets that did achieve a stable that did achieve some stabilization. So as long as it's between 1 and 5, you should be good. Alright, so now no miss is going to be your data set. Let's check to see that all your relevant variables are imputed. So let's do a quick summary of no miss. So as you can see over here, so again, variables Q1 through Q23, we do not have any NAs. Alright, so that means we did it correctly. So all the relevant variables are imputed. The next fun part is to put the partition and imputed data sets back together. Let's call this filled in, and let's just say this is the no people one because we are binding using the cline function the don't column. Remember, that's the data set that contains the columns that we didn't want to impute, but now we're adding the columns back into your final no miss, well, not final, but your most recent no miss data set. Let's run that. And you can actually use this data set fill in underscore no people, and you can name it whatever makes sense, whatever name that makes sense to you. But you can use this if you wanted to remove people listwise. You'd use this second data set if you wanted to remove people pairwise. So I'm just going to call this filled in complete rbind. Notice R stands for rows and C stands for columns. So we're binding the rows filled in from the filled in underscore no people. And now we're going to add in the don't people rows from that don't people data set. All right. Let's check to see if the variables have shifted in terms of, in the process of you binding them. So let's do names. Oops, forgot to put this in. Names filled in underscore complete. Go to my parentheses. Sorry. Did I not write that incorrect? Sorry. There you go. All right. So we have general level advising Q1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 23. So it looks like none of the variables have shifted. So that's great. And that concludes the video on how to visualize the data, analyze missing data patterns, and to impute data using the mice function to do multiple imputation. Check out my next video to figure out how to identify outliers, as well as checking assumptions under parametric types of tests.